Thank you, Ellen. Thank you all for coming today. I will actually call my guest on stage, starting with Nassim Haramein. Yep. And Riccardo Adami, Professor Riccardo Adami, if you can join us. And we're going to see there. Do we need a mic? First of all, thank you, Ellen, for your invitation, for your trust, to support you in Venice and your endeavor is a bit like supporting the early vision of Jane Goodall. So thank you for that. Welcome. Are you here? Are you ready? Settle? First time in Venice, correct? Do we have two other mics so we don't... one is coming. Oh, maybe one is enough. So this is Nassim's first time to Venice. No, your second time, correct?
I used to come here when I was a kid because my aunt lived in Venice.
In Venice?
Yeah, so when I was a bambino, I used to come here and play with the pigeon.
That's amazing. I've never heard that. You're a man of mystery. And Riccardo, you've been to Venice before.
Several times, yeah. Several times because I'm Italian and then you are obliged to come here and it is a very, very beautiful obligation. So I repeat it every time I can.
Well, I think we all, once you come to Venice, you have to keep coming back. So welcome to the third Summus Forum of Unlimited Possibilities, dedicated to the theme of quantum intelligence. We heard before about social intelligence. The ministry talked about human intelligence. Now we're going to talk about quantum intelligence. You'll sound what it means. They will hopefully explain it to us. Together with the recording live of a special episode of OI, the Outsider Insight, a platform that was actually launching today, connecting science, philosophy, consciousness, and so forth. So please follow us if you can. So here with me, you just briefly met them, two amazing friends. I'll try to summarize their curriculum. I think it's going to be impossible, so please don't be upset with me. Nassim is a theoretical physicist, the founder of the Resonance Science Foundation. Is internationally known for his theory that unite quantum physics, sacred geometry, and the structure of the universe as a united field of information, which is fascinating enough to start. And Professor Riccardo Adami, Chair of Mathematics for Quantum Engineering and Quantum Cryptology at the University of Turin. Welcome to the heart of Venice, San Marco Square. And let's dive right in. Nassim, can I start with you?
Sure.
Actually, we might have a short audio recording from an amazing astronomer that I wanted to reference starting this panel. I don't know if we have it. If we have it now, we'll play. If not, we'll play it at the end. Carl Sagan, is it coming? No? After? Which? That's... Okay, sorry, I am not an expert in this. So this is the podcast I mentioned you. I thought this was automatic. And by the way, both of them are already on a previous episode. And Nassim was with Deepak Chopra on the episode that is launching today. And Riccardo was with Andrea Bariselli, a biologist, a neuroscientist. They will go air in a couple of weeks. So here is Carl Sagan sending us a message from outer space.
We were hunters and foragers. The frontier was everywhere. We were bounded only by the earth and the ocean and the sky. The open road still softly calls. Our little terraqueous globe is the madhouse of those 100,000 millions of worlds. We who cannot even put our own planetary home in order, riven with rivalries and hatreds, are we to venture out into space? By the time we're ready to settle even the nearest other planetary systems, we will have changed. The simple passage of so many generations will have changed us. Necessity will have changed us. We're an adaptable species. It will not be we who reach Alpha Centauri and the other nearby stars. It will be a species very like us, but with more of our strengths and fewer of our weaknesses. More confident, far-seeing, capable, and prudent. For all our failings, despite our limitations and fallibilities, we humans are capable of greatness. What new wonders undreamt of in our time will we have wrought in another generation and another? How far will our nomadic species have wandered by the end of the next century and the next millennium? Our remote descendants, safely arrayed on many worlds through the solar system and beyond, will be unified by their common heritage, by their regard for their home planet, and by the knowledge that whatever other life may be, the only humans in all the universe come from Earth. They will gaze up and strain to find the blue dot in their skies. They will marvel at how vulnerable the repository of all our potential once was. How perilous our infancy. How humble our beginnings. How many rivers we had to cross before we found our way.
How many river? Nassim, what, I mean, there's so many...
I'm going to have to correct you already.
You'll have to correct Carl Sagan.
No, your introduction of me.
Oh, good.
Yeah.
Please do.
Yes, I don't do secret geometry, I just do geometry. Yeah, and I've unified quantum mechanics with general relativity using geometric functions. Yeah.
Okay.
Yeah.
That's even better, I think.
Yes. Well, it's more precise.
So, precisely on these, Nassim, you often explore how life is connecting by a quantum network of energy and consciousness.
Yeah.
Inviting us to radically rethink the concept of intelligence, which is the title of this conference, as a collective and a universal phenomenon. Can we call that quantum intelligence?
Yeah, I think so. It depends what we mean by quantum. And first of all, thank you so much for having me. It's fantastic. It's a great honor. Thank you so much. I would say that at first I would like to say that intelligence is never artificial. That might be why our translation system is not working right now. I wanted to, I think it's really good, Massimo, what you just said. I think that intelligence comes from a very profound, deep level of quantum oscillation information network that exists at the very deep level of quantum mechanics, a level that was actually discovered at the end of the 1800s, that has to do with relationship between fundamental constant that defines length, mass, forces, and that are fundamental to the structure of space, meaning that information, and most importantly, information flow, information transfer, dynamic of information through a fundamental oscillating field that's occurring everywhere that makes up everything we see, is fundamental quantum intelligence, and it's everywhere. And eventually it's self-organized in very complex systems. There's more proton in you than there is stars in the observable universe. And eventually produce what we call self-awareness or consciousness or intelligence.
Thank you, Nassim. Riccardo, what's your you know, because I know for you, this is also a new paradigm that you like to explore without fear.
Yes, it's time to go beyond what we are used to. So you use the word paradigm. I just want to recall what do we mean by it. It was introduced by Thomas Kuhn. He was a physicist and then a philosopher of science in a famous book whose title is The Structure of the Scientific Revolutions. Basically, what Kuhn says is that there are two phases in science. One phase, which is a revolution, where everything changes, and this everything can be summarized in something called a paradigm. The basic thing that we don't say each other, but we agree. And then there is a long period of normal science. If you want to be very schematic, big ideas are in revolutions, and big computations are in normal science. Now, at least in physics, we are in a very long period of normal science, so a very long period of big computation. And there are, however, there is not really a crisis. In general, revolution arises from a crisis, from a big crisis like the one at the end of the 19th century. Now it is not really a big crisis, but it is clear that there is something that cannot be explored in this paradigm. And one thing is the conscience. When I was a student in the 90s, I met this wonderful book by Roger Penrose, Nobel Prize for Physics.
Which Nassim knows very well personally.
I can guess. And I was really astonished because he proposed this, to study consciousness. I did not understand how was it possible to think as a physicist and study not the matter or the energy, but something so abstract, so individual. Now, after 30 and more years, I can say that Penrose was one of these visionaries. And if you read this book now, it seems to be incredibly contemporary. It is almost 40 years old, but there are main ideas that are waiting to be developed and perhaps to generate a new paradigm.
But just to say, so for you, the intelligence is not left just to calculation. So there is a word beyond intelligence that probably is much richer than just calculation, which we often tend to reduce it to.
It's fantastic to talk to Massimo because his question requires answers that first, I don't know. I just know a little part. Second, they will need really days and nights of discussions and so
well,
on.
That's a role of the outsider. Give us your clip.
I just will try to give a hint. Referring to Penrose, in this famous book, Penrose says that there is something which is beyond algorithms in our minds, if you want. There is something that he calls insights, and can be seen in some special mathematical results like Gödel's theorem, first of all. Second, since it is quantum, and quantum mechanics is my job, I go back to my job, so in a more comfortable zone for me. So in quantum mechanics, there is an old motto that says, shut up and calculate. So normal science, big computation.
Is it a university mantra?
It was explicitly or less explicitly say when I was a student. It was coined by David Mermin, but it was not Feynman. In fact, I did a research. I discovered that it was David Mermin, who is a physicist, but it was ironic. But it was taken seriously by the community, and I was educated like that. Now it is changing very rapidly, because people are tired of doing big calculation. Calculation are becoming too big for us. So we are starting going back and to see whether it is possible to have some critical point of view about the paradigm and to go a bit far. I just make an example, and then I have been too long. So in quantum mechanics, it is always said that every question about the trajectory of a particle, like position and velocity, is meaningless. You cannot ask, you will never observe, and perhaps it doesn't exist. And I was educated like that. I cannot think about that. You ask me that, your question is not valuable. Now we are going back and see we are not obliged to think like that. And this is a message of freedom for people who studied physics in the last century.
Nassim, were you told the same, shut up and listen?
Oh, plenty. Yeah, but I'm not good at that. I'm just not good at shut up and calculate. The reason there was shut up and calculate, and I'm going to disagree with you, I think physics is in crisis. I think the world in general is in crisis, and physics has a role to play, a very important role to play, to give humanity what it needs to get past this crisis. But because for 100 years, there has been nothing, zero, in terms of fundamental physics discovery. It's always been shut up and calculate, and it is the result of theoretical frameworks that are completely, I'm gonna excuse my word, asinine, that have, that are built on smoke and mirrors, calculation that make no sense, meaning that don't have physical meaning. So a new world of physics was developed from these founders, giants, Einstein, Bohr, Max Planck, and so on. From there, you have this field that emerged that's called mathematical physics. And because of shut up and calculate, we're driving theories that are non-analytical, meaning they have no closed form for the solution. They don't give any fundamental meaning to what we are calculating. That is, we get an answer. It might be the right answer. Since they don't have a closed form solution, they don't give a precise answer. They give an approximation after years and years of computing. And they don't tell us anything fundamental about the nature of reality or the nature of mass, energy, gravity, electromagnetic field, charge, electrostatic charge. All these questions are not addressed. And so this is mostly the fault of the educational system, which takes geniuses and tell them to shut up and calculate. And this is something I'm very much opposed to, just by my nature, as you can tell. Can be pretty spicy. This is very fundamentally what needs to change, and it needs to go back to, let's do real physics, that is physical theory that makes sense ontologically, physically, philosophically. Then let's do the math and do real math, not approximations, meaning like analytical solutions, math, to understand what is charge, what is mass, what is electromagnetic field, what is gravitational field. Fundamental questions which, if answered as they are answered, will liberate humanity and bring us to the next level of evolution.
Which is the part that you very much share, because your view far in the distance is actually a pretty radical view compared to the traditional view of Italian physicists. Am I right?
I'm a bit more optimistic. I'm not. My judgment about the physics of the last century is not so tough like Nassim, because really I try to use the Kuhn framework, revolution and normal science. The description he gave is a perfect description of normal science, and for historical reasons, sociological reasons, and so on. Probably it was almost inevitable to follow through this path. Now I think shut up and calculate is not a topical way of doing physics. Now it is not possible. But
that's why I wanted to move on to the shut up and calculate. I want to know
just one word. Through this physics, we have all the technology we are using now. We are using every day. So. Okay, big calculation, but not always wrong. Something good has been made.
But then, what is quantum physics for you, and what and what do you think will make a difference? Where you think will make a difference?
Okay, quantum physics for you. Quantum physics is a fundamental theory that was born from the works of Planck, Einstein, Bohr, and Heisenberg. Max Born, always forgotten, but he was very important. Many people. So it is a physical theory, which, like all theories, has a history, has a beginning. It will have an end sooner or later, in the sense that the limits of applicability will be found. What is for me? It's a love story. No, in the sense that so it's a love story which is for sure not monogamous and probably not reciprocated, but it's a love story in the sense that
it's like being in the limbo.
Yeah, it's like many love stories, and it started by the surprise. By my astonishment in the face of a mystery. There is a famous experiment which is called the two-slit or double-slit experiment. I was 23, I was at university, and a professor told us this experiment, and I was really opening my mouth like that. It was, this is incredible, this is impossible. I want to devote some time of my life to understand this. Okay, up to now I've devoted almost 35 years to understand this point. So it was, sometimes when you fall in love, it's because you don't understand the person. The person is surprising, is very beautiful, there is something to understand. And if this astonishment keep on being alive, probably also your love can last very long. And this is my relationship with quantum mechanics.
Wow, sounds a beautiful one. Nassim, I want your opinion on something, because you often refer intelligence as something, it's not something that we are, but, sorry, not something that we have, but something that we are.
Right. Right, because we think of intelligence as something, as some intellectual mechanism that's occurring in the brain. From the physics I wrote, I can clearly see that actually the brain is is acting much more like an antenna to an intelligence that is already present. It's present in your body right now. There's actually quadrillions of chemical change that are occurring in your body right now for you to be alive every second. Like I said, there's more protons in your body right now that there is observable stars in the universe, about 10,000 more. There is, you know, molecular, intermolecular relationships that are occurring that are critical to your existence right now. I see all this as extreme level of intelligence present at all scales of existence. So that's why I don't think of intelligence as something that's manufactured in the brain, but something that is inherent to the nature of the material world.
Fantastic. So let me open the conversation, and maybe I'll start with you first, Riccardo. Try to bridge the gap between quantum physics and consciousness. Nassim will talk later about the meeting we had with Federico Faggin. But in the meantime, can you explain what does quantum mechanics have to do with consciousness? And I know it's an historical question, not just a today one.
Yeah, it is a historical and intricate, and let me make it simple. In quantum mechanics, there is something which is really weird, and it is the following fact, that if you don't look at a system, if you don't look at a particle, the particle, or better, its probability, but think of the particle, evolves in a certain way. And in particular, it spreads. The probability of finding it somewhere spreads. It is spread, widespread everywhere. But if you look at it, the particle collapses in one point. More precisely, the probability of finding the particle. But I'm a mathematician, so I have to. So the particle collapses in one point. And so there is an open question since 100 years. How is it that observing, measuring a system changes it in such a dramatic way? And it is exactly at this point that the idea of consciousness is taken back from philosophy and put at the center of the scientific investigation, because some also very great physicists and mathematicians like John von Neumann and Eugene Wigner at some point talked about consciousness, not a very clear way. But of course, you are almost obliged to do that, because when you acquire the information on the system abruptly changes. So it seems that consciousness has a role. It seems there are many theories which are conflicting between them, but one possibility is that. And so this role is then evolved and better specified by people like Roger Penrose. Very quickly, Roger Penrose says that in our brain, he knows that in our neurons there are the microtubules, and in the microtubules there is protection enough to keep the quantum nature of the molecules alive, so the molecules can start oscillating in phase. And this is a typical quantum phenomenon. Quantum phenomenon is fragile. If you put it on the rain, on the hail, on the air, it breaks. But in microtubules, it is protected. This is the hypothesis. As far as I know, there is not a clear experimental confirmation of this hypothesis. Another hypothesis comes from philosophy. There are very famous philosopher, David Chalmers, talking about consciousness. There is a famous paper of Chalmers with Kelvin McQueen, and they try to propose a model in which this collapse is somewhat spontaneous, and consciousness works together with this collapse. Then there are other, and this uses also another consciousness theory, which is not quantum, that comes from Giulio Tononi. And another theory is the one formulated by a very famous engineer, Federico Faggin, the inventor of the microchip, together with Mauro D'Ariano, a theoretical physicist from Pavia. Perhaps Nassim is much much more into it than me. So,
yes, actually, let's pick it up on our meeting with Fajin. And I mean, if there is anything you want to respond, feel free, yeah?
Yeah, you know, Riccardo gave us the typical Copenhagen interpretation of quantum mechanics, which I disagree fundamentally with. I disagree fundamentally with because it's absolutely, and you should know that, mathematically non-rigorous, right? The collapse of the wave function is just thrown in, parachuted into the equation. They just, oh, we're going to collapse the wave function, and we put the equation in. And so, you know, I am much more on the side of Einstein, which famously said the God doesn't play dice with the universe. That is, the physics is most likely not statistical in nature, and that there is a mechanics underneath this that we haven't understood. So I agree much more with the views of de Broglie and Bohm, so Bohmian mechanics, which needs modification as well to be accurate, but that is actually just fluid dynamics. That is, particles are in a field, and they are oscillating within a field. And actually, my equation shows that mass and energy result from this field. And because they're interacting with this field, when they move, they make waves. So they're not in some kind of superposition magic of quantum mechanics, of wave and particle. They make a wave when they move, just like a boat makes wave when it moves on the ocean. And when you have two slits, it makes interference pattern because the wave it made and the particle going through the slit interfere with itself that way, not in some magical way. And when you put something to measure the particle, the thing you're putting in is making waves as well, which interfere with the waves that the particle is making. So you're changing the result of the experiment, not because of some magic, not because a cat is alive and dead at the same time, okay? This whole story, I'm just blown away that it was sold to intelligent people for over 100 years. And so I disagree as well with the fact that, you know, 100 years of the math we did has produced all the technology we have. There's actually zero technology on the planet right now that comes from those math. The technology we have today comes from the math that was written at the beginning of quantum mechanics from the great people that wrote it. You know, most of what we do actually with very simple Newtonian mechanics. And so all this is like a big balloon that was inflated. This idea that and you know, we've built large experiments to support the balloon. I'm sorry to be so harsh, but I'm just saying it the way it is. And we have collided things to get better idea what atoms are made of, right? So we've collided things together to make particles, to see how the atom is produced. And I think we got good idea of how the atom is produced all the way down to the proton, the nuclei of the atom, and the neutron. I think everything after that, that is the standard model, is general bullshit. Yeah, because they call these smaller particles fundamental, so then the proton is no longer fundamental by definition since it's made from smaller particles. However, these smaller particles, they produce in accelerators. The longest lived one live about 10 to the minus 8 seconds. The shorter lived one lived about 10 to the minus 25 seconds, the Higgs boson, which is a whole other story. And so they don't even live the blink of an eye. The blink of an eye is like the time of the universe for these particles. And so, you know, to think that you're producing a particle that you're calling fundamental, but when you produce it, the universe gets rid of it immediately, does not recognize it as fundamental, is a huge issue that is completely unaddressed in particle physics, because it promotes billions and billions of dollars of accelerators and huge institutions of, you know, physicists work and so on. And so, you know, again, I'm saying these are not fundamental theory. They're not ontological. They don't tell us anything about the universe and how it works fundamentally. And certainly, you know, what has been discovered in the accelerator at CERN has never produced one iota of advanced technology.
We'll get to consciousness right after, and I haven't forgotten. Go ahead.
Just to add one word, I will disappoint everybody. I will disappoint Nassim, I will Massimo,
It's
and
okay.
everybody.
The beauty of this is to have different opinion.
No, the point is that my opinion is not so different. In the
Well,
sense
good.
that I was talking about collapse. I was talking what he called, and it is called the Copenhagen interpretation, just to introduce how historically consciousness entered into the game by these guys, Wigner and von Neumann, who believed, so to say, in Copenhagen interpretation. But it is not at all my point of view. And moreover, worse, I agree with you also on Bohmian mechanics, because it is my point of view too. I'm not, and to prove it, I wrote a book, and you can read on it. But but it is in Italian, but your Italian is very good. But however, just to clarify what I think.
Is this the book you mentioned?
Yeah, it is the only book I wrote, so it is that. But
your first book?
Yeah, my first book.
Oh, wow.
Yeah, so what I want to say is that people in the 20th century learned quantum mechanics at a deep technical level, but they were sort of indoctrinated about the interpretation. The interpretation means what is the vision of the world that you have based on this theory. And I was told that it was the only possible one, the one with this particle that collapse, with cats that are alive and dead, the particle that passes between through two holes, and so on. When I discovered this other interpretation, Bohmian mechanics, who was a sort of secret. Nobody was allowed to talk about that. David Bohm was a student of the famous Oppenheimer. Oppenheimer didn't like him, so he managed to send Bohm to Brazil. In Brazil, Bohm formulated this new theory. He sent it to Oppenheimer, and the answer, not the answer to Bohm, but how Oppenheimer reacted, it is well known. He said to his collaborators, if we cannot disprove him, we have to ignore him. This is the most anti-scientific way that we have to approach that. So I don't want to explain you what Bohm says, but my wonder in front of the two-slit experiment and the photon passing between the two slits was resolved when I saw the interpretation of Bohm of this experiment, which is extremely clear. Extremely clear doesn't mean that everything becomes simple, natural. Quantum mechanics is never natural. You can choose the interpretation you want, but you have to accept something strange. What you have accept always is non-locality. I don't know whether we will talk about that.
No, but you said something beautiful.
We agree.
Let's clap. Let's clap. It's very rare to find two scientists agreeing in such a short time.
I'm really sorry. I didn't know.
And it's particularly true what you said, which I've learned by spending time with many, many scientists. Scientists, the worst thing that scientists don't like is to be ignored. That's for them, it's the worst that goes them crazy. So Nassim, back to you, to the consciousness.
Oh yes, so I forgot that part. All right, so Well, when we take the Bohemian mechanic approach, many spiritual people get upset because then they say, oh, but you're removing the magic of consciousness out of the equation. Oh, please don't do that. And that drives me nuts because, in fact, you're actually saying something much more profound about consciousness. And what you're saying that's more profound about consciousness is that actually everything interacts with everything because of this field of interaction, this fundamental. And so that everything is actually modifying everything else. And it's the result of all non-local information that reality comes to be. Like the observation of all points in the universe producing every other points in the universe. So it's much more profound because it's telling us that actually we're in contact with a very profound non-local field, and we have non-local accessibility in our awareness, in our consciousness. Now that's a push on the interpretation. I'm talking non-rigorously right now, although if you take my equations, it becomes rigorous, but that is not a mainstream equation, so I just want to make that clear.
Fantastic. Thank you, Nassim. Riccardo, should we, so we talked about the book. What about your view on quantum mechanics revolutionizing the sense of space? Its non-locality, because that has precise limits, but the rest.
It is, however, connected with non-locality. This is what is called non-separability, basically. And it dates back to Einstein. And me too, I agree much more with Einstein than with Bohr. By the way, for non-expert people, in history of quantum mechanics, there are Bohr, Born, and Bohm. They are different. And sorry. So Bohr was one of the founding fathers of the Copenhagen interpretation. So
but they were no brother.
No. They
It would have been scary.
No, also. And in 1935, Einstein wrote, together with two collaborators, Podolsky and Rosen, a very famous paper, one of the most cited papers in the history of physics. And it is very curious because if you look at it with very rigid eyes, it is wrong. What he says is wrong. But it is extremely fertile on on the consequences. So it is a 4-page paper, but I read it 30 times, and every time I see something new. But the conclusion of Einstein and collaborators is this. This quantum mechanics is an incomplete theory, is not complete, unless you admit something that Einstein called later in a letter spukhafte Fernwirkung. In German sounds much better. It is spooky action at a distance. Spooky was a way to despise it. It's not possible. So Einstein says quantum mechanics is incomplete unless there is a connection between, an instantaneous connection between faraway systems. And then there is a story, also Bohm enters into this story, and then another scientist with a name that starts with B, and is made of 4 letters, which is Bell, very important, very famous. And at some point, first time in 1972, by John Clauser, it was verified that there is this spooky action at a distance. But then after 9 years, and this is due to an Italian physicist whose name is Giancarlo Ghirardi. It is not well known because his proof was secret for many years. It is a strange story.
Is he still alive?
No, Ghirardi passed away in 2018, if I remember well. But it was demonstrated that it is not really an an action at a distance, but something that was called a passion at a distance, a connection between systems that by itself cannot convey information, but it is a strange connection, a so-called strong correlation, which in my opinion has not been understood. So, and this correlation is very strange, this passion, because it does not decline with distance, like for instance gravity. Okay? If you push the Earth far away from the Sun, then the gravity of the Sun is much weaker. But this correlation cannot become weaker if it goes away, and it is somewhat instantaneous. But nothing can be conveyed instantaneously. So the way to think it is that space, in certain cases, loses its meaning. It is like space was not there for this sort of experiment. In this sense, the idea of space has been revolutionized in a way that I'm not able to fix it, to understand very well. Perhaps Nassim is.
Yes, Nassim, please.
I love it. I love it. The paper that Riccardo was talking about is a paper that led to entanglement ideas. And so that was a great description of it. What's not as well known is that in the same quarter, I think like 2 months later, Einstein wrote another paper in 1935 that described the structure of space-time in terms of little knots. What he was trying to do with another physicist called Rosen, he was trying to describe particles. He was trying to get rid of quantum mechanics, the way it was formulated, because there's problems with infinities and singularities and all this. And so he was trying to describe particles as the structure of space-time itself, like that space-time makes knots at certain scales and makes particles like the proton, the nuclei of the atom that has most of the mass of the atom in it. And so he wrote this paper. Most people know this paper, even physicists are confused about it because they know the paper as the paper that led to the description and the understanding of wormholes. Okay, because the equations lead to this idea that that space can form like filaments, wormholes that connects two distant points instantaneously. It's a consequence of the equations of general relativity, the equations of Einstein for gravity. And the end of the wormhole in his paper with Rosen is like the mouth of the wormhole is the particle. So he was describing the particle like a little black hole that leads to a wormhole. And somehow he had just written a paper about entanglement, but he didn't put the two together, which was put together much later by Montesina, I think 2005 or something. Wow. And with this idea of ER, Einstein-Rosen, equals EPR, Einstein-Podolsky-Rosen, which is the other paper on entanglement, like equal, meaning that entanglement, the reason particles are connected at a distance is because they're mini black holes that are connected through Planck scale wormholes, which is something I had concluded in very early on in the 90s, and that I wrote physics on. And so, I think the solution to we don't understand the space because somehow particles are connected at a distance is to actually not get rid of the space, but realize that the space is interconnected at the quantum scale through filaments of wormhole, and that particles, the nuclei of atoms, most specifically protons, are mini black holes. Now, if you take a proton and you make it a mini black hole, as I did, and you calculate the force that that black hole produces on other mini black holes' protons, you get exactly the measurement of the force we see that we call the nuclear force. So this is my big battle with the scientific community, is that we invented a force that we call the strong force because we didn't know how protons hold together, and it just happens to be a classical force we call gravity, but at the quantum level. It has a different range. That's because there is a Yukawa potential that comes into play when you get close to the close to the event horizon of a black hole. And that Yukawa is not considered when we apply black hole theory or general relativity to the universe. And that's why we're missing 96% the mass of the universe. We call it dark energy and dark matter. And so all this comes together and resolve all these problems. Getting that through is being quite difficult because I have to overcome 100 years of shut up and calculate.
We are back to that. Wonderful, Nassim. Thank you. Riccardo, I'll let your last question, then you're off the hook. So, hearing Nassim, I can visualize it, this enormous quantum studies taking forward and sort of changing the nature of what we know, changing the traditional silos nature of what we know. Is that, do you think, a revolution into the making or into the coming?
So it's a delicate question that concerns also the study about consciousness. The fact and also the strength of a scientific theory is not only in its beauty, in its mathematical perfection. The point is that sooner or later, every theory must be confronted with experiments. And in many fields, as far as I know, for the fields of consciousness, I'm thinking of Penrose's theory, it is early to have experiments because sometimes they require too much energy, so too much money. And for instance, the discovery of a Higgs theory, the practical experimental discovery of the Higgs boson happened several decades after Higgs predicted it. And so there is this delay in many theories which are at the border of the paradigm, and so which potentially could lead to a revolution. So there's sort of waiting for that. So I would say potentially there are many elements of an incoming revolution, but practically the community must somewhat be forced to think that it is true, that I have to change. Because the community is, like everybody likes the comfort zone, cannot follow every new proposal of paradigm. And moreover, there is a strange phenomenon. I like very much a statement by Max Planck, the first guy who used the word Quantenstück, the quanta, in his work of, it was exactly in the 1900. And he says, it is not true that the scientific community changes its mind. What is true is that the people in the scientific community, by the time, die. So there is a new generation who immediately is able to understand the new thing. And it is sad, but I think it is true.
Let's hope that both of you will not die soon, but you will stay longer with us. Actually, so there's a lot of things we are learning that you both have in common. I mean, now I just heard Max Planck. I would like Nassim to take on that Max Planck pulse frequency and introduce the sort of notion of biological structure. And in doing that, I would like to call on stage Professor Paco Calvo, which is the next speaker, but maybe we have a smoother transition into the next panel. Riccardo, you are free to go, unless you want to stay. But thank you very much. Thank you.
Thank you. It's so great to meet you. Hey, nice to meet you. Yeah.
So, Nassim, your
Yes.
your
So tell me the question again. I'm a little confused.
You know, I would like to talk. I would like you to talk about biological structure.
Oh, okay. Yeah. So you know, one of the biggest problem in physics is like a big kind of like sore thumb in physics is biology. Like there is no such thing that can exist in current physical theory. In the standard current physical theory, biology cannot exist. And
you are not a biologist, I hope.
This is not going to be such a smooth transition from physics to a philosopher of biology.
Even better, so we are safe.
Yeah. Because there is nothing in current standard physics theory, I'm just talking about the standard theory, that would predict that such organization can occur. Like, it's insane. Biology is insanely complex, insanely advanced. It does crazy stuff. And it clearly seemed to know what it's doing because it keeps doing it. It's not just, it's like I tried to calculate the probability of a single molecular structure developing out of, arbitrary interaction of chemicals in the universe. And I arrived at like a probability of 10 to the 196, possibility, like something that exceeded the time for like many, many universes for that to happen. And then it could maybe happen, in this incredible, like basically zero possibility thing, but somehow it happened. And then, oops, there's a rock that fell on it. And then it would be like another billions of universe before it happened again. And so, like, the idea that life develop under random function doesn't add up. Now, when you talk to people about this, they get very uncomfortable because they think the next thing you're going to tell them is that God did it because somebody organized it, there's this problem. And so physicists in general stay away, because they don't want to even go there. But there's another possibility, and that is that information has feedback. Then we see feedback everywhere in nature. And when a system has feedback, it can self-organize very quickly. It produces fractal structures, which we see everywhere in biology. And this feedback function of space-time, which can be described very fundamentally and rigorously as a feedback between the electromagnetic field, the information radiating away from a center, and the gravitational field, the information collapsing back into a center. And so when you have fundamental feedback in information, you can have self-organizing system, very advanced, relationship interaction, and then eventually maybe a system that's complex enough that the feedback is strong enough that the system becomes self-aware.
Paco?
Wow. Well, yeah, it's kind of difficult to jump in the middle of this discussion and without you knowing first who am I, what do I do, right? Yeah, please say. So I'm Paco Calvo, I'm a philosopher of cognitive science, and I have founded a lab called the Minimal Intelligence Lab. It's a minimal intelligence lab, by the way, is not about the intelligence of plants. I study plant intelligence. Thereby people might say, hey, plants are minimally intelligent? Why minimal? No, I mean to say that we humans are minimally intelligent in not quite getting their intelligence, their full-fledged intelligence, right? So it's about that, our intelligence, not theirs, right?
This is not good news for vegetarians.
Yeah, it is. No spoilers. We'll get there.
Okay.
Yeah, I'm used to people saying, "Hey, I'm a vegan, now what?" Something like that, right?
No, yeah.
But anyway,
You're killing intelligent animals.
Yeah, absolutely.
We call plants, right?
Yeah, no, but anyway, yeah, I think I can resonate with most of what I heard thus far, both in the introduction, the people who were on stage before, and the discussion you two were having. So we'll get to that later, but just in the specific focus of this discussion, I think actually we have a problem in between, thinking that either you have to think of mechanisms, components, things in the head, right? Like either at the quantum, molecular, cellular level, whichever level, but the mechanistic or a reductionist understanding of intelligence or consciousness. Where is it intelligence? Where is it sitting? The nuts and bolts, right? As opposed to emergentist approaches, right? Think of a flock of birds, of a school of fish. Think of emergent phenomena that defies this reductionist understanding, right? And I think we can have it both ways, right? So for one thing, I resonate with especially two things you both said. One is like, what counts, my motto is what counts is not what's inside the head, but what the head is inside of. So it makes no sense to try to search for intelligence or sentience within the skull. If I crack open your head, I won't find it, right? And yet, we want to think that at some point it has to do with this quantum level or molecular level or cellular or whichever level of aggregation we can think of, right? So in a sense, I think we need to put in perspective the idea of everything being intrinsically relational. It's not about the organism, human, plant, or bacteria. It's about the way it engages or interacts with the surroundings. Everything is relational, right? And in being so...
Feedback.
Sure. That has to do with this idea of, the reciprocal feedback, the loop, closing the loop, right? So as you close the loop in between perceiving the surroundings and acting onto the surroundings, thereby, this is where the seat of intelligence pops up, in the closing of the loop itself, right? So I think that's one thing, we'll get to that later, I think has to do with human arrogance. So I think we are an arrogant species, Homo sapiens, right? And we are so focused on either being right or being wrong, or my theory being correct and yours not being correct, or we will wait for them to die and the next generation will get it, and that sort of thing, right? And I think that only speaks about our failures or about our human actions, scientific or not, right? And I think we can go deeper by thinking that we can actually try out all those potential solutions in parallel, simultaneously. And not just in parallel, actually, by teaming up with rivals. So this is what we say, teams of rivals, right? So when you speak of unlimited possibilities, I think those possibilities can only be unlimited if we think hard of a new education in which this is not about winners and losers, right? So in that way, we can think of, for example, biology, going back to your question. I think that where there is life, there is mind already, right? And that is quite consistent with other panpsychist approaches which go way deeper and say, hey, mind, mentality, sentience, awareness can be spread all over the universe across living matter and non-living matter. And yet, that might be the case, but that is compatible or consistent with studying a subset of systems in which you might equate mentality itself with life. And by the way, that's another way of, or another entry point to this idea of, hey, those AIs, this crappy translator that is not doing such a good job today, it might not be intelligent or sentient insofar as it's artificial and it's missing something that we do have, that we do share across the tree of life. The very same way that microtubules, right? So if you speak of quantum properties of cells, of molecules, in the very same way that those microtubules are shared across life. In the tree of life, you find them. And that is, for example, one of the reasons why you can anesthetize a plant. You can put the plant to sleep. I will talk about that, right? Plant cells have those same properties. So I would like to think that we can try to find, to identify what is it that unites us all despite diversity. So we are unique, we are idiosyncratic, and at the same time, there is something that we all share. I would like to think that we can find that master key that allows us to unlock, to crack open any branch in the tree of life. So that's the way I see biology and mentality. The two come together.
Nice.
I think we have crashed already 10 minutes on its time. Yeah. Paco, the floor is all yours. Thank you very much. This is your machine. Thank you, Nassim. Thank you, Riccardo. Thank you, Helen.